god, you are actually the best.
Are we ready, guys?
But
But you're ready? No, but yes.
No, just like give it like maybe another 30 seconds.
30 seconds, okay.
Of processing.
does A have no discontinuities?
Why are you spoiling?
Spoiler alert!
What is that? Medium triangle? Near points.
Wow.
Good one, Simon. I like it.
Negative 2. This is
What is it?
what is distributed. Oh my god, I hate my life. No, it's okay. Just remember to I hate distributing.
This thing is so stupid. No, this is. That wig is really missing something.
Why do I still have an H? Oh, you should put it in. No.
I want to have like an empty space here.
Okay, so you don't need to do that.
Right?
So put your X.
Remember, we plug in x plus h anywhere there's an x. So x plus h quantity squared minus 2 times x plus h, and then subtract all of f of x. So subtract x squared minus 2x
Plug something in.
all over h.
No, this is an answer.
Okay, so
We're good? Okay.
But then you
I'm
put
not
zero.
like totally speaking a foreign language right now.
See, that's what I'm wondering. Where?
I plugged in x plus h. This is the whole thing we did last time.
So you plug in.
2x plus 2.
So I have to find f of x plus h. So x plus h goes in here. Right? Squared. Minus 2. Instead of x, I put in x plus h.
Oh, okay.
Minus f of x, so minus this whole thing. And then
Something has
all
to be. I mean, we
over
got that
h.
one.
Okay, that makes sense.
Close enough.
And again, you can do it as a whole step. I'm going to go to the side and kind of do some simplifying because I don't feel like writing all of that in it. So x plus h squared, guys, that's x squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x. So what is left out of all of that? Yeah, that's gone. That's gone. So can I jump right to this, guys? So I'd have 2x plus h minus 2.
11 minutes late.
You with me on that?
yeah.
Okay.
Yeah,
Cancel. What do I get?
Yeah.
2x minus 2. That is f prime of x.
Oh. See, we did it.
Now again, today you're going to learn how to do that in one step. So,
Do you think we can guess it? Wait.
Oh, you just ignore the H.
so over here, do you see what I had left?
Yeah.
Oh, you mean at the end? Where did it go? So I evaluated the limit by plugging 0 in. Yep. All right, we okay with that?
Yeah. They made it before I
Noticing something
Mm-hmm. Yeah, that's going to come into play today. Well,
Using allergy medicine to make my allergies.
yeah, you seem more sneezy today.
Can't take the bus, so.
I remember my little days. I was so
All right, guys, so looking for any sort of discontinuities here. On the first one, the only potential discontinuity is where it changes from one graph to the other, so where x is equal to 2. So all I need to do is plug in 2 on each and check. Do they match? You can do the limit notation if you want. I didn't ask for it in that way, so you don't have to. You can just go, okay, 2 times 2 minus 3. What do we get? 1. 2 squared minus 2 times 2 plus 1. We get Okay, do they match?
Yes.
Yeah, so you would just say this is continuous.
Get these wheels off. Really.
All right.
I'll start second.
Okay, second one. You have two types of discontinuity in this one.
I'm analyzed text.
I can find the rhetorical
Okay,
situation.
so we have an asymptote,
I think it's on tomorrow.
also called
Oh my gosh,
infinite,
what do you spell tomorrow?
just so you're familiar with the term.
This by itself.
Axis, two X's.
At x equals what?
Two, just split them into words.
Where's the asymptote happen? Positive 3, yes.
We are going to.
And then what else do I have? Whole.
Where is Monroe?
That one's also called removable.
Movable?
Removable.
Oh.
Removable. Not just movable.
Is it an identity or is it not?
Well, if you just had, if I just gave you this and said graph it, what would you put at x equals 3?
0. Like,
What do you get when you plug in a 3?
1 over 0.
Okay, is that okay?
No, it's undefined.
Oh,
It's
okay.
not.
Yes, there you go. All right.
Do you have to plug in? Do you have to get the paired for whole, like the whole? Because that's what I did. Like,
That's fine. Yeah, did you tell me whole at, and you gave me the point,
1 over negative.
Oh, wait, I think
Negative
quarter
3.
is the fault.
and then
Negative 1 over 6.
negative 1, 6. Yes, agreed. That's great too. Yeah.
Okay.
All right, guys. Any questions before we start the notes?
Is it on?
On your paper today.
What's the title? And the number?
Good question. 11.5, I think.
Okay, wait. So if we have an AP exam when we have our lovely test, what do I do?
Take it before, take it after. I don't care.
What
Like-
if I miss the class after that
We'll figure
and
it
I
out.
miss one of the lessons?
Advisory? I don't know. We'll figure it out.
It's so annoying. I hate AP exams.
They are disruptive.
I was genuinely so upset. So originally they didn't have me scheduled for my A-push one, and I was so ready not to go, and my intent was to ask for it again. And I was like, I was so ready not to take it. It was a free out. Like the worst decision. I'm not gonna do all my again. Also, the best part is that almost everybody failed our last test.
Oh dear.
And he proceeded to blame all the students instead. He blamed all the students. Unit 8, we all failed.
I like the idea, like, if one student fails, it's on them. If an entire class fails, I did something. You
The
know?
class average was a 1 point something. And he blamed all of us. He's like, you guys are not working hard enough.
I'm just
And now he's making us do another test before the end of the year, even though he promised us that was our last one. Because we all did so poorly. College.
All right,
Actually,
guys.
just kill yourself.
Power, product, and quotient rules. There's a few other rules in here too, but I didn't want to put more in the title. It just seemed long enough as it was. So. All right, so I'm going to give you a few examples and see if you can come up with the rule. So this first one, if I tell you y equals 7,
4.
no.
That was close.
We'll draw a line. We'll do derivatives on the other side here. Y prime
Yeah, we're actually.
equals 0.
Wait, we're still doing derivatives?
These are the rules for derivatives, just like the shortcut rules for derivatives. You don't have to write limit anywhere today.
Yes.
I'm at my limit with that.
Y prime is the first derivative. So like the derivative of this function is 0. Yeah, I could say y double prime, that's second derivative. We'll get to that stuff in skill 12, usually, most of it.
Oh.
Okay, let's start again. Let's say y equals 3. What do you think the derivative of that's going to be? 0. Let's say f of x is 9. What is f prime of x? 0. Okay, you're catching on. First rule is not.
0.
You're like, we got it. 0. Everything is 0.
Oh, because it's a straight line.
Yeah. You got it.
Constant.
Constant rule. I know that's not in the title. If you're given f of x equals some constant, f prime of x will always equal 0.
Oh, that makes sense. Because it's the line that's like, tangent?
Yeah, tangent. So if you have a horizontal line and you follow it,
It will always be, yeah.
it like follows this way, yeah. Right, guys, your line y equals 7, that's a horizontal line. The tangent, you just follow that horizontally, so slope is 0. Okay, so constants are easy. The derivative of a constant is always 0.
And the whole has to be constant.
Yeah, everything is a constant. All right, let's try again.
Let's try.
So let's say, let me write all of these and then we'll see if you guys can find the rule. So if I start with y equals x squared, y prime is 2x. Y equals x cubed. Y prime is 3x squared.
Where?
Let me write them all, you'll see it.
What is this picture?
F to the
Are you sure we're
prime
gonna-
x
Yep.
This is Snurber.
negative x1. Okay.
This is really funny.
Yeah, no, this is really.
All right,
this
just
is
look
real.
for a minute. Write them down, look at it, talk to each other.
I think this is where I get
But it's the
No! This is what allows you to do the stuff we did last class very quickly.
kidding. I never did.
Oh, I see
No
it.
giving
I
up.
see it. There's
I
a
did
pattern.
x
like-
minus 1 over 2.
Yeah, that was the original one of the coefficient.
Okay. Let's look. Let's look.
What do you do?
That's what it says.
It's just the original power.
And then when you get the
Okay, good start. Exponent becomes the coefficient.
negative, and
Does the exponent stay the same then?
Yeah, it goes down.
Yeah, that's it.
Oh.
This is called your power rule. So if we start with f of x equals x to the n, the derivative, f prime of x, is n times x to the n minus 1. So guys, let me just flip back to our warm-up.
oh my.
Look at that. If I apply the power rule, bring the exponent in front, subtract 1. The exponent of that one is a 1. Subtract 1. Oh, look. Okay.
Wait, the exponent,
Wait.
Isn't the exponent on that one 1?
right.
Oh, you're
Whoa, one more time. One more time.
Oh, so you
You just literally just killed that.
I'll pay you like
calculator.
one.
so you
So let me write it
multiply
again.
the constant.
What was it? X squared minus 2x.
Yeah.
Okay, so first term. Exponent comes in front. Subtract 1 from the exponent.
Yeah.
Okay, this exponent is a 1 to start with, right?
So it's 0.
Oh.
So if I bring that in front, times the 1 that's already
So you're
there.
multiplying the 2 by it already.
Mhm. And what is x to the 0?
Oh.
Oh, I didn't understand you had to multiply it still.
Yeah.
So that, so
Yeah,
that
if there's a
also-
coefficient, you
The
multiply it.
exponent doesn't just erase the already there
Nope.
coefficient.
Nope, it's just
So if it was like 2x
multiplies with it.
squared,
It'd be
you'd multiply the
4x.
So
2.
basically,
4x.
it's
Yeah.
saying
Yeah.
in the power rule, n is in front of.
Let me show you. Let's just do one more real quick. Let's say it was like 3x to the 5th.
Yeah.
It would be like 15x to the fourth.
Yes.
It would become.
Oh, wow.
Well, because you take the 5, you put it in
Much
the
faster
bracket,
than doing the
subtract.
limit definition with
Okay.
x to the
Cool.
5th. Sounds terrible.
That's-
All right. We'll do a lot of practice with those, but that's the idea.
Keep it rolled there.
You're telling me I never have to do it like the other way again.
I would agree.
So every once in a while, I might, like there might be one question on your test that's like, use the limit definition. But you can certainly check at the end with the power rule and go, oh, okay, yeah, I got this
Oh,
right.
they'll be the same.
Mhm.
Yeah.
Yeah.
Yeah, if they're not the same, it's not a problem.
Hopefully it won't
I was
be a
bad
hard
at that. I don't do that.
All right, this one really just is kind of what we were talking about. It has another name, but. So guys, what do you think this derivative is going to be?
3x squared
Is that
and then
good?
3.
Plus 3, yeah.
Nice. Wait, was that? That was just a guess.
Let's say my function starts as 2x squared minus 5x plus 4.
Equals 2x squared minus 1.
It's gonna be a 4x. Right?
Mm-hmm. 4x and what else?
4x and then minus
5 and
Mhm.
plus 0.
Yep. You don't have to write the plus 0.
It just
But yeah, the
disappears.
derivative of a constant is 0, so I'll move this up a
Wait, it just disappears.
little. Mm-hmm.
Because
Because it's 0.
Okay.
Yeah, derivative of a constant is 0.
Oh,
Let's
it's right.
look at it all coming together, guys.
This is gonna be.
There you go.
Better than this.
This is a great way to start the week.
Yes.
Yeah, I kind of like that. I can get behind it.
It's a good birthday lesson.
Is it because where the constant is equal to 0?
Yep. All right, one more in this rule. How about 3x cubed minus 4x? No.
It's probably
6x squared.
6.
9x. 9x squared. Minus something.
If you bring the 3 in front, it multiplies by whatever's already there.
Oh.
top of
Oh yeah, you take
9x squared minus.
Yeah.
That's the difference of squared.
Oh, very good. All right, guys. So this is essentially the product, or I'm sorry, the power rule just used with each individual term. We call it the sum or difference rule, but really it's the power rule over and over.
So why did it?
But we'll write a rule for it. So let's say, I know you're not going to like this, I'm changing up letters. Let's say P of x is f of x plus g of x. Right, so we have multiple things being added together. Then P prime of x
Yeah, I understand.
is f prime of x plus g prime of x. It just means take the derivative of each individual term, and then you can still just add them together or subtract them.
I just
That's what that
power
means.
rule, and I'll look at the other thing.
You're like, I knew how to do it till you wrote that rule.
Honestly.
How many rules are there?
We just have product rule and quotient rule left.
Okay, I'm gonna need to fit this on this one.
So notes are not that long today. We get through them pretty quickly. So
Wait, do we get a math space after this?
That means I can set.
we might do a quizzes, and then you'll still have time for math space because, I mean, we have an hour left of class right
I
now.
think that would be perfect time for math space.
That sounds like time for this.
Previously.
So we're gonna commentate. So I was like, I'm telling you.
Okay. What am I doing? Oh, you need me to pause? Okay, sorry. That's what whoa meant.
Apparently so.
Okay. Do we use something similar to the product or the power rule?
Kind of. I'm showing you one that you could do with the power rule, and then I'll explain the product rule from that. So.
I like doing like the power.
Like, can't you like put the 4 in
It
front,
makes me feel powerful.
and then you multiply them, and then you
I'll explain.
No.
All right, guys. This one I'm not gonna just show you and have you figure out the pattern because it's less obvious than the other ones. I think your brain might hurt. So I'm gonna go ahead and give you the product rule, and then we'll do this one with the product rule. You could also multiply this out and do it with the power rule, so we can check. So you'll see that they are equivalent, and then I'll give you one that it's less fun to do without with multiplying. So, product rule. Okay, this time P of x is equal to f of x times g of x. Okay, function times function. The derivative is g of x times f prime of x plus f of x times g prime of x. So it's really just each individual one times the derivative of the other plus vice versa. Yeah. So in this little thing I gave you, x to the 4th is like our f of x and x cubed is our g of x, okay? So we'll come back down here and try to use our rule to find y prime. Let me wait a sec, make sure we've got it written down.
Well, I love lip gloss, but it's also those infuriating glitter. Like,
Okay, so let's go through it, guys. So what is g of x? X to the 3rd times, what is f prime of x? 4x cubed, good. Plus, what is f of x?
X to the 4th.
Yep. What is g prime?
3x squared.
Okay. So we can simplify. What is x cubed times 4x cubed?
4x6.
Good. Plus, what do I get when I multiply the others?
3x.
Good. So overall, what is my answer?
7x.
Okay. Can we see how the product rule works? Okay. It's not that bad. So let me just prove to you that that was accurate. Let's go back over here. If I start again with x to the 4th times x cubed, well, what if I just multiply that from the beginning? What is that? Okay, and what is the derivative of that? Oh.
that's what.
What?
Why would I do it the other way?
Well, you need to learn the product rule because sometimes, and we're going to get into the chain rule where you might have, that's not today, that's far away, but where you'll have like 2x plus 3 quantity to the 5th times 3x minus 7 quantity squared. Yes, you could multiply that all out and then do the power rule. Or you could know the product rule and the chain rule and use that. Okay? Because some of them they just
Don't
you
worry.
can't multiply. I mean you can, but it's like
It's like
Assuming
so
that
slow.
problem, I'm assuming the problem is real big, not something, right?
you can. All right, so let's try another just product rule one so that you can practice it. So I will give you f of x equals x cubed minus 5x squared times x to the negative 2. Find this with the product rule. Could you multiply it out? Yes, but please practice the product rule on this one, okay?
That's the negative 2.
That is to the negative 2. So this is, you know, this first one, this is your f of x. This one's your g of x. Try from there, okay? Check in with each other. Are you getting an answer that you feel like isn't right?
Yeah.
You're probably right.
No.
Did you get 1?
No.
Oh. Okay.
I'm screwed.
That is more than certainly not what I got.
Okay. Well, shall we go through it together?
Yeah, sounds like a good idea. I go in 1 second.
Oh, and yeah, guys, my f of x and g of x, I see what you mean. I should have said p of x equals. All right.
How did you get 1?
I like distributed these.
How do I mess something
So
up?
like when you multiply x
Wait, where did you get that?
to the negative third,
Everyone told me that I do it.
it's because
You subtract 1. Okay. Oh my god. I can't math. I actually cannot math.
I'm just gonna do my thing and hope that works.
Holy.
All right, let's look at the first step.
So they multiply.
Did we get that? X to the negative 2 times 3x squared minus 10x plus x cubed minus 5x squared times negative 2x to the negative third.
Oh, I see.
Okay.
It's the minus 3 exponents.
Did you guys go -1 on that?
I literally just multiplied it out.
Oh, okay.
Yeah.
So, I mean, you absolutely can get the derivative that way on this one. But I want you to practice the product rule on some simple ones so that when they get messy, you aren't like, oh, I don't know the product rule. Okay. All right, we're simplifying. So I get 3x to the what? 0 minus 10x to the what? Okay. And then if I multiply here, it's going to be minus again. Minus 2x to the what? Okay. Plus 10x to the... Okay, what happens with the 10x's to the negative 1? They cancel, right? What is x to the 0? 1. So I really just have 3 minus 2, which is 1. Finn.
Wait, where do you get the minus 2x to 0 plus 10x? Oh.
I've distributed. Okay. You got to be comfortable with exponents, guys. A lot of negative exponents. You'll have fraction exponents. Okay.
Oh, yay. That is the opposite of yay.
Yay. Sort of. All right.
Rest of the class is to
Wait a second here, and then we'll do the quotient rule. Quotient rule and one more example. That's it, guys.
So close.
It is similar.
You know what we should do? One day we should get like we should rent like a boba tea truck or something, and we can just like all go outside and get boba tea.
That would be really
I
cool.
want to do like
Please. Or we just get an ice cream truck.
Yeah, we're 5, 6 miles. First allowed that should be paid for the little one should be like a good.
Wait, I love that. And then you can get a great. Find the derivative of this ice cream, you can get it. Please, we need more.
Happy with
They
that,
should
Bill?
really have an ice cream day.
That'd be really cool.
Why do you keep adding all these variables?
We've been using. Oh, did I switch from P to Q? Well, I did P for product and Q for quotient.
But then you did P for some distance.
Yeah, because I just needed something else.
You should do for delay. Because I always do N for decay.
Dude, I love that.
Sorry, guys.
That's so fun. Oh no, what is
All right, when you do your quotient rule, it's going to be g of x
No, I'm
times f prime of x.
And it's gonna be
But instead of adding, what do you think it's going to be?
minus.
Minus.
Slight. It's slight.
Now, the weird part, it's over g of x, that whole thing squared.
Oh, come on, man. Wait,
Why?
It's how it ends up working out with your denominator when you have a fraction when you're dealing with it.
That's so
Wait, is that Q of X?
100%
Yeah,
I'm
for
forgetting
quotient.
Oh, Q of X and then
that. I am not gonna remember the little g of x at the bottom. I'm gonna be so proud of getting the top part done, and then I'm gonna forget about that.
So I'm assuming it equals G of X times. So that's not a Q, right?
Yeah, those are g's. So it starts off very similar to the product rule, but with a subtraction instead of addition. Just got to remember then over your denominator squared. I think it's 36 now, guys.
Yeah, in.
Whoa, 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 whoa. What's that supposed to be?
Shoot.
Oh no, looks like I ran out of paper.
What?
This is right over here.
I mean, no, what?
What?
I would never. Oh my god. No.
What?
Is that?
No, that's just x squared. Sorry. No weird letters in this, guys. That one's just y's and x's, okay? All right, guys, use the quotient rule. See if you can figure out the derivative. Yep, x squared minus 3 over 4x minus 1.
Wait, is that X squared or Q squared? I'm blind, I'm sorry.
X squared minus 3 over 4x minus 1. I'll move it up a little for you.
It's small enough for me, I'm
That's fine. I'll rewrite my
sorry. I should wear
x.
my glasses.
And guys, you don't have to multiply out the denominator. You can just leave it as the quantity 4x minus 1 squared
Oh.
if you want to.
Thank you so much.
Yeah.
That's so appreciated, actually.
So, I'm assuming it is the rule.
Use the rule.
The rule. So, G of X. Constant disappear. It's minus.
Wait. Can we just back to the top? That would actually be counterproductive now that I think about it.
Yeah.
We're just going back some.
I mean, you would like take a 2 out, but that's not really going to do anything for you, so.
Oh no, I'm actually.
Wait.
That's actually so unfortunate.
Do you do the factoring distillate?
You don't have to factor it. Nothing's going to cancel.
Okay, cool. I guess I just.
So you just
You could take a 2 out, but there's really no reason because it's not going to go away.
Okay. So then I guess I just leave it at the bottom. Oh, can you just leave it like that?
Wrote my 12 weird. Sorry, guys. Yeah.
No, Rohit, you cannot.
no. There's an exception specifically for you.
Wait, why isn't it plus?
Whoa.
Why is no
Why is it
what?
plus 12? Because the stupid negative.
Negative,
Yeah.
negative. Yeah.
Star, distribute negative.
I always try to distribute the negative.
No, it's so easy to mess it up.
Is there a way to go back?
That's so tragic.
I don't have a
It's called finding the integral. We don't really do that
That's
anymore.
a
We
lot
get through all the
of
derivative stuff.
Right.
Save integrals for calculus for you.
Just because I say so.
How'd we do, guys?
That it? You did good, actually. Okay, good. You're good.
For the formula, if you're struggling at all to remember it, some people like to, I don't know, this just helps them. Low D high minus high D low over low squared. You can,
You know what happens in both
What is
ways,
low?
bro.
low is the denominator, high is the numerator. So that helps some people. They're like, okay, low D high minus high D low. Like that just can stick in their head.
Okay.
But
what is
you
that
don't have
for?
to. It's that formula just in like a weird, it's fine if you can just remember
Yeah.
that. Some people need a little,
Low D high.
so denominator times derivative of numerator minus high D low, top times derivative of bottom.
Turn in our thing today.
Oh, low D high minus high D low.
And nobody wants to do
Low
that.
squared.
Yeah.
Low D high. You know what? I'll read that. Yeah.
It's just if it helps you. If you're like, nah, I got it, that's fine.
It's like speed run 8 for somewhere. No way.
It's like, I don't know what this is even saying.
Minus high.
So I just like
Low squared.
Did you know like Braddock had a school shooting back yesterday?
Whoa.
And then the school went into lockdown and the students left.
What? Oh my god. It's not. What do you mean they left?
Smart.
They escaped.
All right, guys. Anybody questions?
You mean they went?
Okay.
Oh, never mind. It happened like a while ago, like a week ago.
Yes. Why do the 1 and the 3 become 0? Oh, when you're taking the derivative. Sorry, I was like, what are we saying? The derivative of a constant is always 0. Another way you can think about it, like algebraically. So, let's say, so there's what it starts with. Isn't that really 3 times x to the 0? Like, does that mean the same thing? Because what is x to the 0? Okay. So if I followed my power rule, what does that become? Yeah, okay. So it does follow the same rule, but it's kind of messy. So you can always just remember constants are 0 for the derivative. All right. Thanks. All right, guys. Partner up.
We're locked in, bro. We're not choking this time. It was my bad last time, so this time it'll be. It'll be my good this time. Trust me. Trust me, bro. Trust me. Mr. Like,
Yes. Can
I
you find it?
I used 2 papers by accident.
Whoa.
It wasn't supposed to be like that.
Wasn't supposed to happen.
Are you having a good birthday so far?
Yes.
I suppose we're like a good start to your day.
Okay.